Next example of homogeneous Pfaffian differential equation. Solve y square plus yz dx zx plus z square dy plus y square minus xy dz is equal to 0. So if you observe the coefficient of dx, dy and dz, so these are the homogeneous function of degree 2. This is a homogeneous function of degree 2. This is a homogeneous function of degree 2. This is a homogeneous function of degree 2, and therefore the given differential equation is homogeneous Pfaffian differential equation. And we substitute y is equal to ux and z is equal to vx in this differential equation in order to solve the homogeneous Pfaffian differential equation. So how we can identify the homogeneous Pfaffian differential equation? If the PQR, if the PDX plus QDY plus RDZ is equal to 0, is a homogeneous, is a Pfaffian differential equation in which this PQR all are homogeneous function of same degree in XYZ, then we say the given homogeneous given differential equation is what? Homogeneous Pfaffian differential equation. So how we can check the P, Q, R are the homogeneous functions? So if you observe the P here, y square plus yz, there are two terms, y square. So in this term, the power of x is 0, power of y is 2, and power of z is 0. So addition of the powers of x, y, z in the first term is 2. Similarly, if you observe the second term, the power of x, there is no x term, means x raised to 0 is there, y raised to 1 and z raised to 1. So if you add 0 plus 1 is addition is 2. So if the addition of the powers of x, y, z in each term is equal, then we say the function is a homogeneous function. So this is the homogeneous function in x, y, z. This is the homogeneous function in x, y, z. Because the addition of here, if we observe the addition of powers of x, y, z, y raised to 0, there is y raised to 0, z raised to 1, x raised to 1. So addition is 2. Similarly, this is the homogeneous function of degree 2. This is the homogeneous function of degree 2. And therefore, all these P, Q and R, all three are the homogeneous functions of degree 2 in x, y, z, and therefore this given differential equation is a homogeneous Pfaffian differential equation. Once if you identify the given differential equation is homogeneous Pfaffian differential equation, then what is the procedure? Then substitute y is equal to ux and z is equal to vx. Therefore, dy is u dx plus x du, and dz is what? V dx plus x dy is dz. So substitute y as ux. So u square x square y as ux, z as vx, dx as it is, and then z as vx, x as it is, z square means v square x square, dy, substitute dy as u dx plus x du, plus y square means u square x square minus x ux dz. Dz is what? V dx plus x dy, x dv is equal to 0. And then collect the coefficient of dx, dx, du and dv. Collect the coefficient of dx, dv. Cancel dividing by x square, or cancelling x square, dividing by x square, because it is a 2-degree homogeneous function, Pfaffian differential equation. So divide by x square. If the given Pfaffian differential equation is a homogeneous Pfaffian differential equation of degree 3, then divide by x cube. So here is divided by x square. We have this u square plus uv dx. Here is v plus v square, x du plus u dx, in this bracket u square minus u in bracket v dx plus x dv is equal to 0. Then collect the coefficient of dx, du and dv. So what is the coefficient of dx? U square plus uv, u square plus uv, plus x plus uv plus uv, coefficient of dx, and plus minus plus uv square minus minus ux, and another coefficient is what? Minus plus u square v plus u square v. Okay, so these are the coefficients of plus u square v. Okay, so after simplification we have this, the coefficient of u square v, u square this minus uv and plus uv get cancelled. So u square plus uv plus uv square and plus vu square. Okay. So this is the coefficient of dx. Then the coefficient of du is this, because du is what here is du x vx. Vx is the coefficient of du, and another coefficient is what, plus v square x du. Okay. And what is the coefficient of dv? U square x minus ux is the coefficient of dv. Dx du dv. And then we have the simplification. After simplification we have this u square plus uv minus uv square plus vu square dx. And then from these two terms take x as common. So what we have, v plus v square du, and in another bracket u square minus u dv. Okay. And then shift this x to LHS and shift the coefficient of dx to RHS. So we have this dx by x minus u plus v plus v square du plus u square minus u dv divided by u square plus uv plus uv square plus vu square. Okay. And then this is the now one variable separable. After this substitution, y as a y is equal to ux and v z is equal to vx, the given differential Pfaffian differential equation converted to one variable separable differential equation. Then we have to integrate it. The integration of LHS is log x, but yeah, we have to integrate RHS also. So in order to integrate RHS, use the tricks that is adjust the derivative of denominator at numerator, or use the tricks given in the previous charts. Okay. So here the simplification is what? Take v as common. So in bracket we have 1 plus v du. Take u as common. In bracket u minus 1 dv. Then take negative sign here. V 1 plus v du plus u minus 1 dv divided by, the simplification of this is what? Take u square common from these two terms. We have 1 plus v. Take uv as common from these two terms. We have 1 plus v. Then take 1 plus v as common. So we have u square plus uv. Then dividing this by both the factors. So this divided by this factor plus this quantity u minus 1 dv divided by this quantity. Separate in two factors. Then 1 plus v get cancelled, and then v du divided by u square plus uv. And here u minus u get cancelled, u minus 1 dv divided by 1 plus v in bracket u plus v. Okay. And then we have to solve this by using the partial fraction. So u divided by v divided by u plus v, take u as common. So factorization. And then a by u plus b by u plus v. So v is equal to a u plus v plus bu. Then substitute u as a minus v, u as a minus v. So we get the value of b as minus 1. And then substitute u as 0, we get the value of a as 1. And so v divided by u in bracket u plus v is equal to 1 by u minus 1 by u plus v. Okay. So substitute here the value of this quantity. Similarly, so this is du, coefficient of du is this. So 1 by u, integration is log u minus log u. So this is negative sign. So integration is integration of dx by x is log x is equal to minus log u minus log 1 plus u 1 plus v log u plus v, integration of this quantity, log u plus v, minus minus become plus, and log minus log 1 plus v plus log c1. So u minus 1 divided by 1 plus v, u plus v. So again we have used the partial fractions here, method of partial fractions. So we have this. After integration, we have this. And then minus. Then use the rules of log a minus log b is log a by b. Log a into log a plus log b is log a into b. So we have, after shifting the to LHS, all these factors. So log x into u into 1 plus v divided by u plus v is equal to log c1. And then x, cancel log of both sides, and then substitute. We have this, and then substitute, resubstitute this u as y by x and v as z by x. So we have this answer. So substitute u as y by x and v by z by x. So after simplification, we have this answer. Okay. So this is the general solution of the given differential equation. So next example, y square plus yz plus z square dx plus z square plus zx plus x square dy plus x square plus xy plus y square dz is equal to 0. And obviously, if you observe, this function is a homogeneous function of degree 2. This is a homogeneous function of degree 2. This is a homogeneous function of degree 2. And therefore, the given is a homogeneous Pfaffian differential equation. Then put y is equal to ux and z is equal to vx. And so dy is u dx plus x dv, and dz is what? V dx plus x dz. Substitute in this. So we have this. We have this after substitution. Then dividing by x square. Dividing by x square. We have this. We have this. And then collect the coefficient of dx, du and dv. Collect the coefficient of dx, du, dx. So first multiply this two terms, these two terms. Then we have this, and then collect the coefficient of dx. Dx, coefficient of dx is this, and then coefficient of du is this. Coefficient of dv is this. Is equal to 0. And then shift this term du and dv to RHS. Du and dv to RHS, and take x as common and shift that x into LHS. So we have minus dx by x is equal to this, v square plus v plus 1 du plus 1 plus u square dv divided by this. And now we have to integrate both sides. So integration of LHS is log x, but integration of, in order to integrate this, we'll find the derivative of denominator first. So derivative of denominator is this. So adjust this at numerator, or use the another tricks. So equation 2 becomes equation this. In order to adjust this, this is v square plus v plus 1 du. So write the derivative this term as a numerator of this equation. So we have this. Then minus. So already there is a term v square plus v plus 1. Out of this, v square plus v plus 1 is there. V square plus v plus 1 is there. So to balance the side, so what do we have? Minus 2v plus 2u plus 2uv du. So if you add this term and this term, then we have this answer. u square plus v plus 1. So so v square, if you observe v square, here is v square. So then if you observe 3v, there is 1v. So adjust 2v, minus 2v is there, minus 2v is there, this term. Then this term, 2u, so subtract 2u, subtract 2u, and 2uv, subtract 2u. So if we add, if we take du as common, and if we find the addition and subtraction of these terms, then we have the answer v square plus v plus 1. So adjust the derivative of numerator at denominator at numerator. So then this term, write this term 3u plus 2v plus v square plus 2uv plus 1 dv. But if you observe the term, there is 1 plus u square. So u square uh, is there, u square is there. Then plus 1 is there, but here is 3u, and in this, if you observe, there is u. So subtract 2u, subtract 2u, subtract 2u minus 2u. Similarly, subtract 2v minus 2v, and subtract 2uv. So plus 2uv minus in bracket this term dv. That is, if you take dv as common from these two, and if we find the addition and subtraction, we have the answer this 1 plus u square. Then minus dx by x as a system, and then this first two terms divided by this denominator, first two terms du dv divided by the denominator, okay, and the plus this term divided by, that is 2, take 2 as common, so we have u plus v plus uv du divided by this denominator is this, okay, and its factorization is this u plus v plus 1 u plus v plus u. Similarly, this term dv divided by this denominator, and then its factorization, and then cancel this u plus v plus uv, u plus v plus uv denominator and numerator. Then we have minus dx by x, this term, these two terms divided by denominator, this plus minus this term 2, only 2, and 2 divided by u plus v plus 1, take common, u plus v plus 1 as LCM, then minus 2, here is du, and here is dv. So plus du plus dv, right here du, here write dv. So we have this, and then integrating. So integration is minus log x, and the integration of this is what? Log of denominator, log of u square plus 3u uv plus v square plus u square v plus uv square plus u plus v minus 2, and log of this, the derivative of u plus v plus 1 is du plus dv. So log u plus v plus 1, and then after simplification, it is log minus 2 log, this means log minus log u plus v plus 1 raised to minus 2, means raised to minus 2 means divide by u plus v plus bracket square, log a minus log b rule, then log a by b, we have this, and adjust the constant of integration as log as c1. So this minus log x means divided by x. If we shift minus log x to RHS, then it is plus log x. Plus log x means into x. So x into u square plus v square plus 3uv plus this quantity divided by log u plus v raised to 2, raised to, divided by, cancel the log of both sides. So we have c1 is equal to x into u square plus v square plus 3u plus u square v, okay, and its factorization, this factor, this denominator, and its factorization is this x u plus v plus 1 plus in bracket, in another bracket, u plus v plus uv divided by u plus v plus 1 bracket square, and then shift the LHS, this factor, After cancelling one factor, we have this, and then substitute u as y by x, v as z by x. We have this answer. Multiplying by x square, we have this answer, and this is the general solution of the given differential equation. Then the next method is Nathaniel's method. So the previous topic is what? Homogeneous Pfaffian differential equation. This topic is important. The theory is important. That is, what is the question on the theory? Explain the method. Explain the method to solve homogeneous Pfaffian differential equation. Homogeneous Pfaffian differential. So this is the homogeneous Pfaffian differential equation. So what is the method? Put y is equal to ux and z is equal to vx, and cancel the x raised to n, and then separate the one variable. It's reduced to one variable separable. So this procedure is also fixed to problem also. The same procedure is applicable to problem. That is, shift the collect the coefficient of dx, du, dv, and shift the coefficient of shift the terms containing du and dv are to RHS, and then take x as common, and then x shift to x as LHS, and then it becomes one variable separable. Then integrating, after integration we get the, and this remaining part, after separating the x variable, the remaining part is what? In du dv, and this is the exact differential equation, and this is the exact differential equation. That's why it is the derivative of some function. So determine that function. Suppose mu is the function, then so this is the theory, and the problems are these. So these are the homogeneous Pfaffian differential equation. So if you identify the homogeneous Pfaffian differential equation, then first check in every example, first check x bar dot curl x bar is 0, and then solve it. That is, it is homogeneous Pfaffian differential equation, then substitute y as ux and z as vx, and then solve. So these are some problems of Pfaffian differential equation. So the next topic is again Nathaniel's method. This topic is also useful to obtain the solution of Pfaffian differential equation, any Pfaffian differential equation. So this is, I think, third method. The first method is what? Variable separable, first method. Then one variable separable, the second method. And the third method is what? Homogeneous Pfaffian differential equation. And this is the fourth method, Nathaniel's method, to solve the Pfaffian differential equation. So this is the fourth method to solve the Pfaffian differential equation. So we will discuss this method in the next lecture.